Hello and welcome to Nature and Environment. And today I'm going to talk about artisanal mining or small-scale mining. Or better still, I'll talk about galamsey as used in Ghana, zama as used in South Africa, and opeya as used in the Francophone countries. Artisanal miner is a subsistence miner who is not employed by any official mining company, but does mine or engage in mining independently using their own resources, especially hand. There are some artisanal miners that have been employed by individuals or enterprises to engage in mining. However, they still count on rudimentary techniques or manually intensive labor. Some of these miners do engage in business all year round. Others also come in seasonally. Now, there are various forms of small-scale miners. We have the permanent miners. The permanent miners are those who do engage in all year round mining. We have the seasonal ones who come in when agricultural activities are inactive. We have the rush type. They only come in whenever there are increases in commodity of other items. So what they do is that they come in to get some money from the mining sector in order to complement or supplement the hikes. And the last group is what is called the push-up. The push-up, they are the very ones who get into this illegal mining or this small-scale mining following a disaster or a conflict. Now, let's look at the global statistics of mining. Like I said, mining is a major issue in the developing world. And so far so good, about 80 countries have recorded mining in their countries. For instance, in the Francophone world, they refer to the small-scale miners as opeyas. In Ghana, for instance, they refer to them as galamseyers. In South Africa, they refer to them as zama. If you go to Kenya, they refer to them in a different way. Congo, so they can be found almost every part of the developing world, including the Philippines. Now let's look at the global statistics of the small-scale mining. About 90% of the global mining workforce has to do with the small-scale miners. And 20% of the global gold supply are produced by these small-scale miners. And 25% of the global diamond supply are also produced by the small-scale miners. 85% of the gemstone is also produced by the small-scale miners. Globally, 40.5 million women, men, and children are directly involved in the small-scale mining. Of these, 30% represent women. Now let's come back and then look at what is, or break it down and look at what is happening in Ghana. So in Ghana, the statistics are also clearly indicating that 20 to 50,000 people are involved in small scale mining, or better so, galamsey. But if you look at the figures, you could also predict that it goes beyond that, because different reports are giving the figures differently. Now, based on this, it has also been estimated that 3 million people benefit directly or indirectly from this illegal mining, or better so, they serve as a source of livelihood for them. Now, there's one thing I want to look at, which is a major area, that is how the operation is done. So in the small scale mining, what they do is that, first of all, they remove the vegetation using shovel, using bulldozer, using front end loaders, using excavators. The way by which they will remove this vegetation depends on how sophisticated the miner is. So with the very basic miners, they use the shovel. The next thing again they do is to remove the topsoil. So the topsoil again is being removed by the use of what? Scrappers, the bulldozer, the shovel, in that order. Now at this point, we can also break down the small scale miners, or the galamseyers, in so many forms. So those who basically, or who use the shovel, they are not able to go beyond this point when they have to encounter an overburden. So they may either one focus on soil with a very deep profile or horizon. Another group that will also come out of this will be those that will be just be collecting alluvium or sediment or colluvium from the floodplain, sieve them, and then try and extract mineral ores from them. So if the miner is so sophisticated, then they are able to break or remove the overburdening rocks or the overburden. And with the overburden material, it usually comes with a lot of mineral ore. So they are able to break it down finally, or crush it down, and then extract the traces of minerals from it. The next thing I want to look at is the how they are able to use mercury to do this. So what they do is that they introduce elemental mercury. So the purpose of the elemental mercury is that it is able to amalgamate or combines with traces of this metal or the gold. Now they become a big amalgam. Now what the miners do again is that they heat this amalgam to cause the mercury to vaporize. Now the leftover is referred to as the traces of the minerals or the gold. Okay. Now let's look at the environmental impact of this surface mining, or the galamsey, or the artisanal mining. Well, the impact of mining on the environment could be described as a chain reaction. What I mean here is that one thing or one effect or one problem or one impact will lead to another, and it will go in that order. So at the end of the day, one problem will lead to multiple problems. However, I will break the environmental problems into three. The first one will be damage to land resources. During mining, the vegetation is removed. Now, what happened is that the soil profile or the natural soil layers are also altered. The next thing that happened is that the beneficial organisms that help in the formation of the topsoil are destroyed. If there's also an attempt to recondition the mined area, usually there is a mix of topsoil with that of subsoil, making the place unproductive. The mining alters the topography of the area. So it becomes very difficult to return to a previous land use, such as farming. Okay, so for instance, if a whole football pitch or double the size is removed, the vegetation is removed, and mining activity has been done over there, what will happen is that we are going to have a big depression there. So if you want to reverse the situation so that you could convert it into a productive capacity, it becomes very difficult. The next thing I want to look at is water resources damage. Some of the pollution caused by the mining activity could be spotted easily. For instance, when there's a change in color of the water, for instance, making it reddish orange, that will give you an idea that the water is polluted. There are instances too whereby some of the pollutants cannot easily be detected. Therefore, it becomes very difficult to say the water is polluted or is clean. And a typical example has to do with the concentration of acid, concentration of alkali, among others. In testing the water discharged from a mining area, there are 4 parameters that we do focus on. One is the pH, 2 is the iron, 3 is the manganese, and then the third one is total suspended solids. With the pH, we are interested in measuring the acidity or the basicity or the alkalinity of a liquid. It comes with a scale from 0 all the way to 14, and then within the middle, that is 7, the water remains or the liquid remains neutral. Now moving from 7 upward, then the water or the liquid becomes alkaline. But moving from 7 towards 0, then the liquid becomes acidic. The pH that we do expect from water being discharged from the mined side is between 6 and 9. Now, there are problems that usually comes with this acid and alkaline concentration at the mine site. One is called the acid mine drainage, and then the second one is alkaline mine drainage. I'll start with the alkaline mine drainage. The alkaline mine drainage, usually it is not a major problem. It's very uncommon, but it does happen, and it happens when an alkaline overburden is exposed to water. Now, the acid mine drainage is a very common one, and it happens when the marcasite and pyrite in the overburden are exposed to air and water. Now, the pyrates, when reacted with rainwater, it becomes sulfuric acid. It's very dangerous to aquatic life. It kills fish, increase water treatment cost, and municipal water supply distribution. It also makes the water unfit for recreational purpose. Now, there's also another problem when it comes to mining. Example, the iron hydroxide. So iron hydroxide that is found in the water environment is so dangerous to aquatic life, and it also increases the hardness of water. I collected samples of materials from the mined site. Now, this is a fresh cut. Look at it. The color is white. It's quite different. It looks like a bit gray and all that. Now look at this one too. We have traces of what? Metals in there. It looks like very gray. And then there's another one here. Okay, look at it. The color is now changed. This is because water or air has come into contact with what? The traces of metal that are in there. So at the end of the day, when it happens the same way, look at this one too. Like, look at it, very rusty. So all this solution will be washed down to the rivers. They'll be taken down, or they'll be eroded by, or they'll be transported by the rain or the water into the low-lying areas, and that will cause a very it will cause so much harm to the aquatic life over there. The next thing I want to look at is the manganese. Manganese is a metal that is soluble in acid, an acidic environment. What happens is that the manganese, which is a metal, is solubilized, and then it gets into the surrounding water. It kills fish and destroys other aquatic species. The next thing I want to look at is the total suspended solid. So with the total suspended solid, we are only referring to all the solid materials, inorganic and organic. So the metals, the traces of metals, the weathered materials and all that will be referred to as the inorganic. And then the organic will refer to the dead leaves, the vegetation, all those ones will also be referred to as the organic. Now, these materials are moved from the original place to a different place as a result of gravity, air, or water. Now, once they find themselves in the low-lying area, especially in the floodplains, they begin to settle over there in the form of alluvium, or in the form of colluvium, or let's say in general, sediment. So they build up, and then they fill the channel through which the water flows. They close up the channel. Now, when there is an excess water or runoff, the channel will not be able to hold this water. Therefore, it will cause the water or the river to overflow its bank, leading to flooding. Another problem that comes with this sediment is that it also becomes a host for pesticide, heavy metals, and bacteria. Sediment again also reduce the light penetration in the water and changes the temperature of the river or the water body. The next thing I want to look at is the mining impact on aquifers. So those who use sophisticated equipment to be able to get into the overbedding, they also end up creating additional problem of either reducing the quantity of water in the aquifer or the quality of water available. How does that one happen? Now, in drilling and blasting the overbedding rocks, at the end of the day, they are introducing chemicals into this environment. Therefore, they are polluting the water that is available to supply for drinking purposes. And mind you, this aquifer supplies about 95% of the global drinking water. So if we destroy the aquifer, then we are also limiting the water available for drinking. The next problem is that in getting into the aquifer and destroying the aquifer in an attempt to extract traces of metal, at the same time you are also cutting off the supply of water from the underground water system into the rivers, into the lakes, and others. Therefore, reducing the quantity of water available to those water bodies. At the same time, in case you also break or you make a punch out into the aquifer, what happens is that you may end up gushing out a lot of water, and that amount of water running down or running downstream will not be able to be managed easily, and that may also bring about what? Flooding. The last area I want to speak to is the wildlife damage. The first thing is that in mining, the wildlife are either destroyed or displaced from the mining area. So this is a temporary damage, but the long-term effect is that they also end up destroying the habitat or the native environment of this wildlife. What do I mean by this? The plants or the trees that are over there, some of the animals living in this area use them as what? Their habitat. Some of the animals are living in the roofs or the canopies of the trees. Others are also living on top of the trees. Then we also have caves that are also found in this pre-existing area, where some of the animals are also what? Using them as their habitat. Again, some of the animals also burrow into the ground and use this opening as their home. Therefore, clearing and destroying all this vegetation and turning the soil upside down and breaking down the rock, you are causing the animals to lose their natural address. Therefore, they become what? Homeless. Another problem that has to do with wildlife damage is the increased concentration of acid that finally end up in the water environment. So what happens is that now we have a lot of acid in the water bodies. They kill the fish, they destroy breeding in hatchery grounds, they reduce population level. In summary, I would say that small-scale mining is a major issue in the developing world. However, a needed attention has to be paid to this problem because they destroy water bodies, they create air pollution, and then they damage the soils as well. However, in addressing this problem, a careful approach needs to be used. Now, in my next presentation, I will look at some of the approaches being adopted in handling the galamsey or surface mining activities. Do subscribe, follow, share, and thank you for your time. Bye.